All right, guys, we're moving on to 9.2 now. As a warm up here, obviously I made a big point of talking about your different types of reflections over the x-axis, the y-axis, and y equals x. So the warm up for today is kind of going over the same concept. So make sure, if you haven't already, make sure you learn the rules for each type of reflection, but also understand them. Don't memorize, understand, because if you try to memorize, you're going to probably accidentally change the x values when you flip over the x-axis, but that's wrong. You should be flipping the y values. Same thing here. People will make a mistake and flip across the y-axis, and they're going to reflect the y values, which is incorrect. So those are always going to be done backwards if you just try to memorize. Anyway, if you know what you're doing here, you can go ahead and write this answer down, pause it, and then check the answer when you're done. If not, and you don't know how to do it, you're going to need to follow along now. Okay, so we have our 3 points, A, B, and C. So for each one of these, we're going to find A prime, B prime, and C prime. Alright, so if you're flipping over the x-axis, again, you just need to understand what's going on. You're going to have a point, and we're flipping over the x-axis. So what's happening is the y value is changing. It's changing from a positive to a negative, or negative to a positive. So this would be 3, negative 4. B prime would be negative 1, negative 4. And then C prime, you already have a negative, so it's going to be 5, positive 2. Again, the y values flip when you flip over the x-axis. Next, we have the y-axis. We're going to have the same basic concept here. We have A prime, we have B prime, and we have C prime. So in this one, the only difference is you're flipping over the y-axis, so your x value changes. So when your x value changes, you go from 3 to negative 3, so negative 3, 4. B goes from negative 1, 4 to positive 1, 4. And C goes from 5, negative 2 to negative 5, negative 2. So there's your A prime, your B prime, and your C prime. And then finally, when you flip over the line y equals x, again, you have this line going through the origin. Again, what happens is you take your point, remember when you flip it over, and you're to your perpendicular line with the line of reflection, your 2 points, you're going to have an x, y value. I like to use this as an easy example, but again, it's just an x, y value, and it becomes a y, x value. Again, I gave you an example with the rule next to it here. So this is the rule. This is just a quick example that I gave you to help you remember it. So anyway, in this case, you're going to flip the x's and y's. So A prime is going to be 4, 3. B prime, that one's going to be 4, negative 1, and C prime is going to be negative 2, 5. Like I said, you know the rules, you know it, but I want you to also understand it. That's how you remember things and you don't make silly mistakes. So make sure you actually understand what those mean, and you're going to remember it a lot longer, and you're not going to make the silly mistakes, like I said. Alright, so that's a warm-up. It's really a review from 9.1. Now we're going to go into 9.2, and 9.2 is going to be on translations. So your goal for today is to be able to identify a translation and then actually draw one. Same thing we did with our reflections. Again, the only difference is we're doing translations now, but same basic premise. Yeah, so anyway, your little lady's dead. There's little cartoons that Miss Moore came up with, so yeah, they're cute. Okay. So, key definition here, know what a translation is. Now we did a translation again in 1.7, so it's nothing new, but a translation is a transformation where all the points of a figure are moved the same distance in the same direction. I guess those are the key phrases you want to go here. Same distance in the same direction. Again, a translation is another isometry because you're going to have your preimage and your image are going to be congruent. So the image of the translated figure is congruent to the preimage. Okay? So again, understand those key phrases as we kind of go through what we're doing today. Or tonight, whenever you're watching this. Okay. Example 1, very similar to 9.1. We are going to tell whether each transformation appears to be a translation or not. So again, what we're trying to do here is see if it moves the same direction and the same distance. So what you would have to be able to do here is take any points. It doesn't matter. I mean, I'm showing you a couple examples of points here. But again, I take any line segment. I put arrows to kind of show direction, but these are line segments. This segment should be congruent to this segment, and in reality, any segment that I draw from one vertice to a corresponding vertice should be equal in length. In this case, you can kind of see yes, it is. So this would be a yes or a yup. I like saying yup. Smiley face. All right. This would be a translation. This next one looks like that we got a reflection going on here, and we already talked about that the other day, or well, depending on when you watch this, earlier. But if I drew a line across the line of reflection or a line segment, those lines would be congruent, or those segments, I'm sorry, would be congruent if I drew a perpendicular, line perpendicular to that. So again, this would be a reflection. So this would be no or nope. This is a reflection. Again, as you learn the other types of transformations, it makes it even easier to recognize the ones that aren't right. All right, again, with that, you should be able to go ahead and try 11 through 14. Hopefully those are pretty simple if you know what a translation is. Okay. So the concept here that I was kind of showing you, you're going to have, in a translation, you're going to have that line that we draw, but it's really a segment, and that's what this word vector represents. Again, I'll explain what vector means. But vectors are actually line segments. But a translation is a transformation along a vector such that each segment joining a point and its image has the same length as the vector and is parallel to the vector. So if you want, I can show you, if I go back here at the previous page here, what a vector means is that it's a segment with direction. So like a line segment would look like this. But a vector has to show direction. So that's what the arrow is. But notice it stops. That's the key with a vector. This is a vector. Again, it's a line segment. Okay, that shows direction. And that's what we're doing here. The direction is telling me where my translation is going, but it is still a segment, so I can label it congruent. So that's going to be, again, a key phrase to make sure you understand, because I know you see those arrows, you think rays, and you think, oh, it's going forever, but it's actually not. In this case, it's a vector. Okay, so in this case, we have our vector going from A to A prime, and you do that with all your points, all your vertices. And you're going to have that arrow going the same direction every single time, and again, you're going to use the tick marks to show that they're congruent for every single vector that you draw connecting each vertice from your preimage to your image. Okay, so these are important concepts here. Okay, so here we go. We got example 2 now. Now we're going to try to do a translation. So copy the quadrilateral and the translation vector. So we're going to draw the translation of the quadrilateral along vector W. Now I want to make sure we make a note here of vector W, how you label vector W. So this means vector W. This is kind of a new thing. Okay, now again, the difference here is the way you draw that arrow. Now we did something like this before with rays, where we would have, an actual arrow on top, but with a ray you gotta have 2 points. It'd be like WB. This would be ray WB. That's kind of the difference. Now there's no B anywhere. You'd be like, where's the B? Well, I just made it up, because you need 2 points to draw ray. So in this case we have ray WB, and it would have the arrow on top. So I'm already saying ray, so I can just erase that. All right, so again, understand difference. Vectors, they stop. The arrow just shows what direction it's going. A ray, though, it goes forever. It doesn't stop. So there's the big difference there. They'll look very similar, but they are definitely different. So what I'm going to try to do something cool here if I can make it work. I'm going to copy that vector. Got to draw that. I got to be real careful. Draw as carefully as I can. And now I should be able to copy it. And when we copy it, oops, didn't mean to do that. Actually, what I'll do is I'm going to go ahead and pause the video, and I'm going to copy these vectors, and you'll see what I mean in just a second. Alright, so what you can see, what I've done here is I've copied vector W, and I actually copied it 4 different times. And what I did with each one of those points is that I started my vector on my pre-image, and I drew the vector going in the exact same direction from each vertice. And what happens here is now I can go ahead and I can draw my image by taking the ends of these vectors and drawing my points. So again, if I called this vector, or this not the vector, the figure, let's call it A, B, C, D. When I draw my image, this would be A prime. Here I'd have B prime. Here I would have C prime and D prime. Again, you just got to connect it. Hopefully your figure looks better than mine. But that's how you do a translation. You copy that vector 4 different times. And as long as you keep track of the length, because that's the important part, that it has to be exactly the same length and the same direction, then you would be good. Now you kind of look here, you know, obviously these are the same length, but notice it's the same direction. You got this, you know, angle that's going down. You need to make sure that you keep that so that all these lines are parallel to each other. Again, I can't really do straight edges too well on here, so it's kind of squiggly. But again, obviously you want to use a straight edge when you draw that. And as I do any of these in class, as I'm going over any homework problems, you'll see that. Same thing with this more. I mean, we'll be drawing, you know, straight lines, not squiggly. I do the best I can with what I got. Okay, so translation's a little, you know, kind of simple if you kind of get the hang of it. You just need to make sure that it's parallel and the same length, each one of your vectors. And if you do that, you'll be fine. Now again, remember you can do 15 and 16 now. Try to draw your own. We can always review those if we need in class. Okay, so next thing, again, remember we skipped around a little bit with this chapter. We kind of jumped, so I'm kind of going over vectors as we kind of go through here. So we're going to put our vectors in the coordinate plane next, so we need to talk about this, and I'll show you that as we go into the next example, but let's just kind of talk about it real quick. So forget the whole recall, because we're not recalling anything unless you've already learned about vectors. So here we go. A vector in the coordinate plane can be written using this notation. Notice those are arrows, they're not parentheses, where A is a horizontal change and B is a vertical change. From the initial point, obviously that's your starting point, to the terminal point, which would make sense, that's the end point. So I'm going to give you an example of a vector before we move on, and this is again a vector that's only giving you the horizontal and the vertical change. So the other name for this, when you have a vector written in this form, it's got a name, so I'm going to tell you. This is called a component vector. Again, we got to do a quick review here because we haven't learned about vectors yet. So this is actually what we call a component vector, and what you need to know about a component vector is the initial point is going to always be at 0, 0 in this case, because they're only giving you one set of values and you have 2 points, so that wouldn't work out too well if you don't know where you're starting from. So from here you got your terminal point, and that's going to be the point AB. Now again, that can change if so let's say they're telling you where that your initial point is at 5, 3, and then they find a way to kind of word it so they give you this. well, then you know to start at 5, 3 and understand A is a horizontal distance, B is a vertical. Again, as we go through examples, you'll kind of see how this works, but you need to understand what a vector is. This is not necessarily just a point. A vector is a figure. So this is telling you how to, start at 0, 0 and go this distance horizontally and this distance B vertically. All right. But again, it's easier to see it than me to talk about it, so let's kind of move on and get to our examples. Okay. Last thing, again, we are getting to our examples, trust me. Okay. Last thing before we move in to that portion, we have translations. So again, understand this is obviously one of these things that's not a definition, it's a concept. So you want to make sure you understand them. Obviously, for quizzes, things like that, you want to know these. You have a horizontal translation along a vector. This kind of goes with what we talked about in 1.7 in an introduction of how to do arrow notation. If you're doing a horizontal distance, you're just adding that horizontal distance. Again, we're using A just like we do with the vectors. A is a horizontal distance. So we're using that in our notation here as well. If I'm going from P to P prime, a horizontal distance A, you're just adding A. So again, notice here, this is giving you that component vector form or format, but notice here if they're telling you that P is at XY, then this is a direction at that point. Okay. Same thing here, we got a vertical distance, we're using that same value B, but it's going vertical, right? So this would be 0B, but again, they're using the vector as 0B because, like I said, we're given the points to start with. Now again, this is a unique thing in geometry because in these situations, you're going to be translating a figure. So not every point's going to be at 0, 0, which is why we're using the component vector format, but we're using it where our initial point may not be at 0, 0. All right, and finally, the general translation along the vector, if it's A and B, you're going to add A and you're going to add B at the same time. So you got your X, Y for your P value, but P prime, you're going right A and up B. It could be down as well, depending on what your vector is giving you. Okay, so this is kind of what we're going to be applying using vectors and vector notation. Okay, so now we're going to go ahead and apply these concepts using example 3, using our actual vectors, our component vector format. So here we go. We're going to translate the quadrilateral with vertices 2, 5, 0, 2, 1, negative 1, and 3, 1 along the following vector. So this is telling you how we're going to translate that vector when we're looking here at negative 3, 3. Okay, so what we're going to do, we're going to go one point at a time. We're going to apply that vector, starting with R. So this is our pre-image point at 2, 5. So what we're going to do to get to R prime is we got to look at our vector. Our vector is telling us to go left 3, down 3. So this is going to be 2, minus 3, and 5, minus 3. So that's going to give us, for R prime, negative 1, comma 2. And we'll label those points as we go along, but let's kind of get all our points first. So we have R prime, so let's do S next. S was at 0, 2. So when we do S prime, we're going to go 0, minus 3, and 2, minus 3. So therefore, S prime is going to be negative 3, comma, negative 1. And just keep following this same process. We have T next at 1, negative 1. So I'm going to go T prime is going to be 1, minus 3, and negative 1, minus 3. Therefore, T prime is going to be negative 2, comma, negative 4. And one more point, we have U. U is at 3, comma 1. So here we go, U prime, same process, 3, minus 3. Because again, we're using our vector, negative 3, negative 3. It's going to go 1, minus 3. So I get U prime, which is at 0, comma, negative 2. So I have my points. Again, find the points first, then you just need to plot them. So we have negative 1, 2. That's going to be R prime. I have S prime at negative 3, negative 1. I have t prime at -2, -4. And I have u prime at 0, -2. So again, we can go ahead and connect these points as best we can. I'll do a better job than that because that's terrible. My first try is always the worst. Okay, that's a little better. Go ahead and connect those points. S and T, and R and U. And again, the goal here is to draw the figure algebraically, but again, just remember if I drew vectors, each vector would be parallel. It doesn't look like it sometimes so my lines aren't straight, but each vector should be parallel and exactly the same length. Okay, and then you have your work. You don't show your work algebraically. In this case, if I'm giving you the points, I want to see the algebra. So I want to see this work off to the side here. That's kind of what I'm looking for. Okay, you can draw your vectors as well if you need to, but this is an algebraic solved problem. Oh, by the way, at this point, again, now you can go ahead and try 17 through 19. Again, any questions, we can always review them in class, but you should be able to approach those problems now. Okay, so next up, example 4, a little what-if question. So suppose, so again, we got our figure here. Obviously, it looks like we've got a marching band going on. You got your 50-yard line and all these things, and this is kind of how they're moving. But let's go ahead and get the details as we read this. So suppose another drummer started at the center of the field and marched along the same vectors as are shown at the right. So the center, I'll try to make sure we can see it. I don't think green would be a good idea on that, so I'll try to use blue. So he's right there at the center of the field. And you think you see your y axis here, there's your y-axis, there's your x-axis, so we kind of made a grid out of this. So that'd be your origin. So what would this drummer's final position be? So what we need to be able to do, you got a starting coordinate, so this would be more like a regular component vector at this point. We need to find what that vector is, however. So what I'm going to try to do is find out what this vector is. That's really what we're trying to find, is that vector. So it's going to give us a horizontal component and a vertical component to that vector. But my goal is, again, to find that vector. I'll just call it vector v. V for vector. And we just need to find the horizontal movement and the vertical movement. And then we can just draw the vector. We don't need to draw the right triangle. But it wouldn't hurt if we did. But here we go. So starting at this initial point, we're going to see how far do they go to the right and how far do they go down. So it looks like it went from -8 to 8, which they're kind of showing you here as 16, 0. So that's showing you that you went 16 to the right. So 16 to the right. And here we went from 8, 8 to 8, -16. Again, you're going down these values, but they're told you the vector right here as 0, -24. So put that together. This is your translation right here. It's telling you to go right 16, down 24. So again, that's what you would kind of be doing as you went through this. We're just trying to find their position. So you can graph it on here if you want, but the scaling's kind of crazy. You have to be able to figure out that you're going, it looks like by 8s. But they're not asking for the drawing. If you did draw it, again, you'd go right 2 and down 3, really, because each point is 8. And you would have your point right here. And your vector should be parallel to it. So again, if I drew that vector, see how it's parallel to the red vector, the red dotted line. It's parallel to the blue dotted line. Because, again, they're the same vector. They're congruent vectors, I should say. Alright, so anyway, they want the point, though. So if you start at 0, 0, you went right 16, down 24. Remember, your terminal point is your point at the end of your vector. So the point would also be 16, -24. Okay, so that point, again, they're not really calling it anything, so they just, you know, what would the drummer's starting coordinates are 0. What would the final position be? Final position is that. Okay, so this is where you can kind of see how, you know, how component vectors are typically worded, but again, because of the geometry that we're doing, sometimes you have to be a little more creative with those component vectors like we did back here, sorry, on example 9, because every point can't be at 0, 0. But typically, in other situations, the starting point, the initial point, is going to be at 0, 0, like it was here. All right, so anyway, at this point, we can try number 20 from your homework. Okay? All right, so at this point, we have our quiz, lesson quiz for part 1. So again, you're going to do that. Make sure you have that ready when you come into class. So here we have 1, 2, 3, 4. So 4 questions. Okay? So make sure we knock those out before you come in. And then we have our assignment. So you can kind of take a look at that. And again, we're looking in the in the book, doing the problems listed. So for you should know, based on what Miss Moore or I tell you, which ones we're working out of, which ones to do. Okay, so obviously you're not doing the textbook and the workbook and everything. So again, I'll leave that up to us to tell you in class, but you should know which one you're working out of. That shouldn't be an issue. Again, notice at the bottom here we have the don't forget to rate yourself. I went ahead and put those on the next page. Please make sure you're scanning the right one. Don't scan Mrs. Moore if you're a student of mine. Conversely, you don't want to, and if you don't know what conversely means, we're going to learn that in chapter 2. Conversely, if you are, and again I said if you're a student of Miss Moore, don't use mine. Conversely, if you're a student of mine, don't use Miss Moore's. Okay, make sure you're using the right one. Otherwise, we won't get it. Okay, and I don't want to start sending things back and forth because everyone's screwed up. So again, I have the link if you need it. That is not Miss Moore's link, that's my link, or the QR code that you can scan. Alright, so go ahead, get your reflections, get that reflection filled out. Make sure you do the quiz and bring that in with you next class, and then we'll finish the homework from there. Alright, good luck, guys.